Hello good people, I'm going to look at this standard deviation problem. As always, I suggest you pause the video and attempt the problem yourself first. Alright, so 26 students have completed a test and the results were as given. I need to calculate how many students have performed within one standard deviation. As it is part of good practice, I'm going to calculate the median and the mode as well. The first step is to list the given values in ascending order. The next step is to calculate where the median position actually is. To that end, I will need the median position formula. And it is n plus 1 over 2. In our case, that would be 26 plus 1 over 2. 26 plus 1 is 27, divided by 2 gives 13.5. This means that the median position is between positions 13 and 14. In my list of numbers, that means I'm looking at these two positions. In order to calculate the median value, I need to take the average of these two values. As both of these values are 16, the average will also be 16. So I can say that the median is 16. What about the mode? Well, the mode is the value that occurs most often. By inspection, I can see that that is the value 16. It occurs 8 times. So I can say that the mode is 16. In order to calculate the mean, I'm going to construct a frequency table. I will have an x column for my values, f for the frequency, and I will also have x multiplied by f. In the x column, I'm going to quickly list all the possible values. In the f column, I'm going to write how often each value occurs. In the x multiplied by f column, I'm going to write the product of x and f. In case of x equals 11, that means 11 times 4, which is 44. I'm going to quickly fill out the rest of the column. The sum of these values is 390. This 390 represents the sum of all x values. And this is something I can use to calculate the mean. The formula for the mean is x bar equals the sum of all x values over n. In this case, that means that I will have 390 divided by 26, and that will give me 15. So I can say that the mean is equal to 15. In order to calculate the standard deviation, I need to add two more columns to my table. Firstly, I will have in brackets x minus x bar squared, and then I will have f multiplied by, in brackets, x minus x bar squared. When x is 11, I will have 11 minus 15, which gives me negative 4, and then I'm going to square that to give me 16. When x is 12, I will have 12 minus 15, which is negative 3, and when I square that, I will get 9. I'm going to quickly complete this column in that fashion. Now I'm going to complete the f times x minus x bar squared column. So when x is 11, I will have 4 multiplied by 16, which gives me 64. When x is 12, I will have 4 multiplied by 9, which is 36. I'm going to complete this column in the same fashion. The sum of all of these values is 187. This represents the sum of all of the x minus x bar squared values. And I can use this when I'm calculating the variance, which I will need to calculate the standard deviation. The formula for variance is variance equals the sum of all of the x minus x bar squared values over n. In our case, that means 187 divided by 26. And that will give me a variance of 7.2. The next step is the calculation of the standard deviation. The formula for the standard deviation is standard deviation sigma equals the square root of the variance. In this case, this means that we will have the square root of 7.2, and that will give a standard deviation of 2.7. This means that all the results that are within 2.7 marks of the mean, which is 15, will fall within one standard deviation. In other words, results between 12.3 marks and 17.7 marks will be within one standard deviation. How many students does that actually represent? Well, I need to look at all of those students who have scored more than 12.3, but less than 17.7. If I look at my table, that means that I'm looking at this group of students, the ones who have scored 14 and 16. So I could say that 12 out of 26 students have performed within one standard deviation. Suppose that this test was designed in such a way that the students cannot score partial marks. In other words, their marks can only be whole numbers. In that case, I would need to round the standard deviation to a whole mark as well. So this 2.7 would be rounded to 3. And now it would be results that fall between 12 marks and 18 marks that would be within one standard deviation. In that case, if I look at my table, I'm looking at all of these students. So the ones who have scored 12, 14, 16 and 18 marks. And I would have to say that 19 out of 26 students have performed within one standard deviation. When solving mathematical problems, it is important to keep the context in mind. All of these values, all of these numbers stand for something, and we need to consider that before presenting our answer. That is all for now, and I will see you on the flip side.